In this video, I'd like to talk about local or relative extreme values and then start a conversation about how to find extreme values, whether they're local or absolute. A function has a local maximum value at c in its domain if f of x is less than or equal to f of c for all x in an open interval containing c. If this were to be an absolute maximum value, I'd require this inequality to be true over the whole domain. Instead, for a local maximum, it only needs to be true for one open interval near the value. For example, if I looked at a function whose graph looked like this, clearly I'm not going to have an absolute max. It goes on forever. But if I looked at this point right here at some value c and only looked at a small open interval, and looked at the y values on that open interval, then this is the highest point in that open interval, making it a local maximum. It's only a maximum if I look close to it. Function has a local minimum value at c in its domain if f of c is always less than or equal to f of x for all x on some small interval containing c. And again, coming back to this example, I'm imagining a graph that then goes down forever on that, so I'm clearly not going to have an absolute minimum. But this turning point here, if I look at a small open interval around it, is the lowest point. And there's actually another local min over here that if I shrink down and look at a very small interval in the domain, then that's the lowest point. And so that's the idea of a local extreme value, a local max or min. Well, let's look at another function and see if we can talk about all of the extreme values. So let's just imagine I have a closed interval a, b, and on that I have a function whose graph looks something like this. I'm going to call this function y equals f of x. And I want to talk about all of the extreme values. And one of the ways I could talk about this would be to ask you to find all of the extrema. Let's find all of the extreme values, and with that set of instructions, I need to find any local mins and maxes. I need to find any absolute mins and maxes. Well, I've drawn a continuous function here on a closed interval. The extreme value theorem tells me there should be an absolute min and an absolute max, a highest point and a lowest point. That really seems to be the highest point to me. I'll call that value x3. There's an absolute max at x3. And again, the y value is the maximum, and I could call it f of x3, but it occurs at the x value, x3. Now I'm looking for the absolute minimum. And I think it's at that endpoint. There's an absolute minimum at A. All right, well, I found the absolute extreme values. Let's see if there are any local extreme values. Here and here, where my graph turns around, I'll call this x value x1 and this x value x2. If I look at just a small open interval around x1, then that looks like the top of a mountain. Right, that looks like a highest point. There is a local max at x1. And then if I look here at what I've called x2, I look at a small open interval around it, and that would be a lowest point on that open interval. There is a local min at x2. And here at B, if I look at B near B, this is a lowest point. And even if I imagined on the other side, there are no y values, and so that is still a low point because there aren't even y values over there. So there is a local min at B. So I have absolute mins and maxes, and then I have some local mins and maxes, those high points and low points, if I only look at x values near where I'm talking about. All right, in our next video, we're going to look at the first derivative test for local extreme values, and that will give us some idea of where to look for mins and maxes.